Yeah. I don't know what just happened. I had to cycle my entire router. So weird. Sorry if we lost anybody there, but so I think there's a good chance we're going to be wrapping up anyway, but wanted to at least come back and say hi and thank you and everything else to everybody because, you know, everybody makes it worthwhile. All right. So anyway, have anything else, Superbrain? Or if anybody else is coming back? Apologies for that last little hiccup there. Router just decided to completely kick me off. Happens occasionally. It's an old piece of equipment, but it's been reliable. Don't know what happened. Yeah, unfortunately tonight I do have to get cracking at a couple of uh, exams that I haven't corrected yet, but so I mean this is my not too great contribution to it. Um, I don't think this is really going to do anything for you, but this could get some sort of oh yeah, that'd be a great idea. So this might get you like some sort of graphical representation of it, but I don't think it's really gonna. I don't think it's really gonna get you anywhere necessarily. Um, in terms of like trying to figure out what the Nash equilibria are for numbers that are not on the borders. Right. Is there some sort of like calculus that you can do for it? I feel like that's reasonable-ish. Yeah. So you are setting up specifically that M is to be used to find the Nash equilibrium, despite the fact that you can't actually use M and 0. Hey, Superbrand, the font is from dafont.com, and it is freeware. So maybe it is similar to, but legally distinct from, the Star Wars font. Somehow. Intrav, heyo. Welcome in. um, well, we can go a bit longer. It's been going all right, apart from a random crash that we just had a few minutes ago, but worked out all right, and thank you very much for the follow. How about you? Do you have any particular questions about of a mathy nature? Because I will be happy to answer any of those. Currently, we're working on a what is supposed to take the student 3 days to figure out. We're trying to do in 20 minutes. This is fine, I'm sure. So, no, I got disconnected. I don't know what happened. Yeah, no problem. So one of the things that we used to do was what was known as Superbrain. You're gonna love this. It was called the simplex method. Um, of course, it was talking mostly about inequalities. So I don't know if this is actually going to work at all, but hmm. Now that I'm saying it out loud, it seems like this is not going to work at all. Um, so it was mostly for linear programming, but it could use any number of dimensions at all. So we would have an equation. And again, we use the utility equation for this, so it's not really gonna work for this. Um, hmm. We'd set up. How do we do this? We'd set up stuff so that everything was on the left, with the exception of any constants. They were always on the right. So this would be like C1 equals 1. C2 MC2 minus 3x equals 0. Hey, Mega Monkeys. So I was thinking about it. I don't know if it's going to actually apply to the problem in particular that we've been trying to work on, but you know, it's worth thinking about it. Yeah. So overall it's game theory. I'm trying to go about it in a very roundabout, strange way, which is probably not going to work at all. So. So a 2mc3 minus 3x. Thank you, Mega Monkeys, for the follow. Equals m. Right, because m is going to be a constant for any particular value of m. It's the x's that are going to be different. So this is going to be like x2, and this is going to be x3. Hmm. Yep. All right, so the for anybody who just came in, the basic idea was that we started with congestion with the equations here, people trying to travel from city A to city B, and there has to be at least one person on every route, if possible. So we want m being the number of people who are commuting should technically be greater than or equal to 3 then. If it is just 1, they can make that decision for themselves, or 2. But once you get to 3, then you want to say, okay, what if we split people up? Give 1 person on every route. That should be nice. Yeah, that's all going to be 1 if that happens. Yeah, I'm not really seeing a way forward on this. So the C sub i's are supposed to be the congestion. So how packed is each route, depending on how many people X are on each route. I believe that this should mean then that each of these X's are X sub I. And so I reflected that over here, which may or may not be correct, but it seemed reasonable. Yeah. All right, and if we spread out as many people as possible, then we end up with 1s in every location. At least for the ones that I've done in my head. So for all values that are multiples of 3. So price of anarchy is going to be related to the maximal congestions, right? Or do I not have that? Could just be a completely separate concept. Hmm. So... Intrav, we... So... I don't typically take images, however. It's possible. Oh, man. Oh, goody. Oh, I see, I see. Yeah, yeah. I got you. Mm-hmm. Oh man, glutton for punishment. Um, Interesting. Okay. And it's not asking for any limits, which is too bad. Man. Who did this to you? Jeez. Is there only one correct answer, or is it like prove all of the following? Multiple of them could be correct. Okay. Interesting. Maybe. N factorial x squared plus n squared. N for all x point the real numbers positive. Prime 2 less than or equal to 0. D f prime at 3 over f at 3 is greater than or equal to f prime at 2 over f at 2. Okay. What? That doesn't seem right. Hang on. How does that work? Hmm. In terms of the rest of these are not x and x squared. That's pretty close. But it's not quite the same. Because again, we're missing middle terms. Hmm. Interesting nonetheless. Well, I think that I'm not really seeing a whole lot here, which is too bad. I'm sorry for that. But let's see. Could. So, somewhat. If we use logarithmic differentiation, that'll at least knock out some of this stuff. So one of the things that we can do is take out all these stuff with the n's as multipliers. So f of x can also be written as the limit as n goes to infinity of n to the n over n factorial raised to the 1 over n power. I mean, it still has to go to the rest of the stuff, but nonetheless. Times limit as n goes to infinity of x plus n x over 2, nope, multiplied by. Let's just not do that. Well, that's good to know, I suppose. All right, so if we take the natural log on both sides, now let's do, yeah, take the natural log on both sides. Natural log of f of x equals, look at the limit stuff. This is all going to be a constant. So if this ends up being this, this could be natural log of the limit plus the natural log of limit n goes to infinity of this big fraction over here. That x over n can come out front. N is still going to infinity here, and that's multiplied by our natural log. So in theory, this is going to be 0. And by orders of magnitude, natural log is going to go slower than rational polynomial. So, yeah, it's rational. So this is going to be the natural log of this limit here is going to be a constant. Then we still have to look at it in terms of we're taking the square root of this thing. So in theory, that should be approaching 1. Hmm. All right, well, I'm not sure how reliable that's going to be, but as the limit goes out to infinity, we're going to have a fraction out in front of this natural log as well of 1 over n, so that's going to go to 0. 0 times our natural log of whatever this is going to be. I don't know how doable this is. All right, let's just imagine that we don't get stuff canceled out yet. If we take the derivative, okay. Didn't really get anywhere. I was just speculating. So if we do the derivative, this is going to be 1 over f of x times f prime of x. It's going to be equal to, this is all going to be 0. That's a constant. That's 1 over n times the natural log of all these multipliers, divisors, all of it. It's all together. And plus x over n times the reciprocal of this thing. So that's our x squared plus n squared. X squared plus parentheses n over 2. Oops. Alright, this one's going to be a nightmare, unfortunately, because of chain rule. Alright, but then this is going to be multiplied Yeah, I know. Could use it to separate stuff out. Oi. Minus all these. Natural log of that. Minus natural log of x squared plus n over 2 parentheses squared minus natural log x squared plus parentheses m over 3 squared minus dot 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 out through natural log of x squared plus n over n parentheses squared. Yeah, true. This chain rule in this case is literally a nightmare, so. Come on. Right, so take the derivative. It's going to be 0 here. This is going to be 1 over n times all that stuff. So natural log x plus n plus dot 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 out through natural log x plus n over n minus the natural log of x squared plus n squared minus dot 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 all the way through to natural log of x squared plus n squared on n squared. Okay, and then this would be plus x over n, where this one is going to have all these values taken under. So x plus n plus all this over x plus n over n minus. So here's an interesting problem. Chain rule is going to make 2x's in front of all these. It's not natural log anymore. So 2x is the derivative of the inside, and then derivative of the natural log is 1 over this thing. So x squared plus n squared minus dot 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 out through x divided by x squared plus n squared over n squared. So this is the original function here. Multiply by all these things. Hmm. Sorry. Yeah, I don't know where they're going with this. To think we could just plug in some numbers. Hmm. Welp. So, Intrav, I'm not sure where this is going to go. If we're saying that all values x are possible, and n is going to be really large, then plugging in these values, a half, a third, 2/3, 1, 2, and 3, feel like kind of a large undertaking overall. I do see one little thing. Yeah. So, actually, in terms of the derivatives, I'm seeing here that these are all 1 over x's, and these are all minus 2 over x's, approximately, but and if we're going to combine those, then we should get something that's on the order of negative 1 over x. Again, not exactly, but close, reasonably close. So then when this gets multiplied by x over n, this should be close to negative 1 over n, which n is getting big and going close to 0. The fraction 1 over n gets close to 0. The other one's got it 2. It's not really helping. Hmm. Yeah, I'm not seeing where this is going, and I think I'm gonna have to sign out for the night. So, um, okay. So thank you everybody for coming. I think I'm gonna sign out for the night. Let's start heading over. I did not see FMYZU or FUMYZU. Thank you very much for the follow. And I think we're going to see if, let's see, Jason? Oh no, Jason's not on. No. Oh well. So Jason Charles Miller is a usual raid target of ours. He does music stuff, and he's an awesome guy. Unfortunately, he's not on tonight, so we're going to head over to Boss Lady B, who is currently playing Minecraft. She is an elite dangerous streamer typically, although lately has been doing some mines and crafts. So, hope everybody has a good night. We'll head on over to hers and see what she's up to. So thank you everybody for coming. I will be back on Friday for gaming stream. We're doing whatever I feel like. So there's a good chance that we're gonna either be doing Heaven's Vault again, which is a linguistics puzzly type thing, or maybe Elite Dangerous lately has been kind of sluggish due to my graphics card being terrible. Um, maybe that'll change eventually. But we might be able to pull in. I don't know. We'll see. Half-Life Black Mesa we've been playing occasionally, and trying to do a run-up to Half-Life 2, and then also a we've been doing a why can't I think of it? Elder Scrolls Skyrim. There we go. We've been doing a Skyrim uh, playthrough, finishing up stuff in order to get a new character going so that we can do that on stream and have some fun with it. I have modded the hell out of my game. I just wanted to finish the one that I was working on before I finished the one I was working on before I did a modified one, but it doesn't really matter. I'll figure it out. At any rate, I'll be back Friday for games and next Wednesday for another math stream, and we'll do some fun stuff there. So, thank you very much for coming. This is Obi-Wan Pez for NSimplex Pachinko. We're going to hop on over to Boss